Hello, here's another AQA A-level multi-choice question on the topic of particles. If you want to try to answer this question yourself, pause the video now. If you got the answer B, well done. If you didn't, here's my explanation. So you'll have seen magically appear over here the part of your data sheet that's going to help you answer this question. So let's have a look at the question. The quark combination of a particle is strange and anti-up. Which is true for this particle? A really good starting point is to draw out a little table that's going to tell you about the properties of the particle made from a strange and anti-up. So I tend to draw a little table that looks something like this. There's my strange quark, there's my anti-up quark, and let's put some lines in. Now, one of the things we might be interested in is what charge we get from this. So there's a symbol Q for charge. A strange quark has a charge of -1/3. An up quark has a charge of +2/3, so an anti-up would have a charge of -2/3. So overall the charge is -1. What about baryon number? Well, you should know immediately that a baryon is made of 3 quarks, but if you didn't, you could still find the baryon number. If you've forgotten that, maybe we could find the baryon number. So the baryon number for a strange quark is +1/3, and the baryon number for an up is +1/3, but remember we're talking about an anti-up, so that's going to be -1/3. So baryon number is 0. So we perhaps could answer a few of these questions. Oh, strangeness, forgot about strangeness, blimey. Okay, so strange quark has strangeness of -1. An up quark has strangeness of 0, so an anti-up also has a strangeness of 0. So the strangeness is -1. Okay, let's just have a quick look through these things. It has a baryon number of 1. No, it's not a baryon, it's a meson. It has a baryon number of 0. It has a charge of -1.6 times 10 to the -19 coulombs. Yes, it does. It has a relative charge of -1, and that is -1.6 times 10 to the -19 coulombs. So that's why B is correct. It's a pion. No. Pions, or pi mesons, where have we got them here? There we go. You can have a pi 0, a pi minus, or a pi plus. They all have a strangeness equal to 0. The K mesons, or kaons, and again you can have K plus, you can have K0, you can have, K plus and K minus. They have a strangeness that is not 0. So it might be -1, +1, etc. That's something you need to know. So is it a pion? No, it's not a pion because it has a strangeness that isn't 0. It has a strangeness of -1/3. Well, you can't have strangenesses that are a fraction, and anyway, we know it's got a strangeness of -1, so that's why D is incorrect. So there's your answer, B. If you found this useful, click on that subscribe button for me, please. Hit the like button, share with friends, and watch more of them in the series. Thank you.